So earlier I was like, hey, I can avoid using slice by writing a bunch of for loops. Scopes is not like that. You can never avoid scopes. Scopes are always going to be there in JavaScript, whether or not you want to. So make sure you actually understand this, because you can't just say like, oh, I'll avoid using it. Um, Scope can basically be thought of as kind of like a sandbox, or like basically it has to do with permissioning at the end of the day. Um, when you write a piece of code, right, like not every variable is going to be available to everyone all the time. And it kind of makes sense, right? Like even just for security reasons, right? Like you don't want someone to know everything about your code at all times. And scope basically is a way for us to set permissions or boundaries, if you will, to determine who can access what or who can see what at what point in time. So um, for us, the concept of scope primarily deals with the idea that, hey, certain variables are only going to be available to you at certain points in time or at certain places. So how does that look? Well, if I create a variable called wow, I console log out the next line, that makes sense, right? I can see wow because I just created, I can see wow on line 5 because I just created it on line 4. JavaScript is lexically scoped, and it basically says the scope of an object, the scope of a variable is determined based on where the variable is being created, not where it's being used, right? So it's kind of like your nationality, your birth nationality is determined by where you were born, right? By not where you currently live, right? I think so. Yeah. So once we create a variable, at that point in time, like that will be the scope of the variable forever, like into perpetuity. Um, and so one of the things we can think about is, well, like it's kind of like you may, if you go back to the nationality analogy, it's like, well, at the end of the day, like everyone is still born on Earth, right? Like Earth is like the global nationality, and so because of that, there's this idea of something called the global scope, which is kind of like the outermost scope, right? The outermost layer of permissioning. Um, and so here on line 6, I create a variable called year, and guess what? I can access a global variable on line 8. But if I create a function, within that function scope, I can still access this global variable called year. In fact, I can access this variable global from anywhere, right? Because it is on the kind of outermost layer, like everyone has access to it. In JavaScript, the idea of scope or scopes, singular or plural, is determined based on these curly braces that we've been seeing, right? So when do we see curly braces? Well, we have to use it whenever we create functions, right? After our function, it has to be open curly brace followed by close curly brace. We also see it after for loops, while loops, if statements, and probably a few other like smaller things I'm forgetting right now too, right? But essentially is whenever you see these curly braces, and we're not using it to create or use an object, then it basically means we're creating a new scope. One of the things here that we'll talk about probably in more detail in a future slide is just this idea that whenever we create a variable, JavaScript actually reads the page through twice. The first time it reads through the page is to figure out, hey, what variables are on the page? And then the second time it reads through is to figure out, hey, what's the value of that variable, right? And the reason why it does that is to avoid something that we saw earlier that we've been seeing in yesterday's lecture, which is called a reference error. It basically means, hey, you're trying to use a variable that doesn't exist yet. So what JavaScript's going to do is the first time it reads through it, it will say, oh, okay, these are the variables that exist on this page. If I see it, I know not to throw an error. And then the second time it will say, oh, this variable that I saw earlier, if the value of it is 6, or the value of it is true, or the value of it is whatever. So that's why here in this example here, we have console.log out, console.log wait for it, then we create wait for it, then we console log out wait for it again. The first time JavaScript reads through this code, it will just say, there's a variable on this page called wait for it. If I see that variable, I know it's something that's going to exist. But because I don't know what it is just yet, the value of it is going to be undefined. The second time it reads through this code, it will try to execute every line of code. It will say console.log wait for it. I know it exists, but I don't know what it is just yet, so it'll be undefined. Then I will assign the value of here I am. And then when I console log again on line 9, it will be here I am. Yeah.
Do you know where that information is stored in between the first read and the second read?
It's on the page. It's not stored anywhere. Or rather, are you talking about
Like when it's being read, does it go into the RAM of the computer?
Yeah, it's always on the RAM of the computer, right? Like when you write the code and you start running it, like the computer reads the code on the page.
Yeah. Okay.
Like it doesn't move it anywhere else. It's just always in the same spot. Sorry, let me just make sure that. Okay, sorry, let's make sure that it was recording still. Okay. Okay, so next up is something called so this function scope, and so this goes back to what I was saying earlier about how one of the ways we create a scope is when we create a function, right? We use these open and closed curly braces. Every time you see those open and closed curly braces, it means we're creating a new scope. And so the way that scope fundamentally works in JavaScript is scope only looks outwards. It doesn't look inwards. If we put it in kind of a more of a kind of like a family hierarchy analogy, right? The idea is like if I have a function and my function has a function, the inner function is like the child function, and then the function that's in is called the parent function, right?
Like an onion.
It's like an onion, yeah, exactly. And so the way that scope works is if I try to use a variable, I will always try to look for it in my own scope first. If I find it, great, I use it. If it doesn't exist, then I look at my parent's function, my parent's scope, to see if they have that variable. Okay, if they have it, I'll use that, and I'm done. If they don't have it, then I'll look in their parent's scope, and so on and so forth until I reach the global scope, right? And the global scope does not have that variable. Then at that point, I'll say, hey, you're trying to use a variable that doesn't exist, which is why we get the reference error that maybe you've seen, throughout the course of the workshops, right? It means literally it's JavaScript has tried everywhere to look for this variable that you have permission to, and it couldn't find it. And so it can conclusively say, yeah, this variable doesn't exist. The analogy I used to give for this was kind of like how like if you're like running low on funds, like you might ask your parents for money, and that doesn't work. You might ask your grandparents for money, and then so on and so forth. But what you probably don't do is you don't ask your kids for money.
Mm-hmm.
No, okay. It wasn't the greatest analogy. I'm trying to think of better ones. But yeah. But anywho, with scopes, like that's kind of how it looks, right? Is that like I look in my own scope first, right? I look at myself first. Then I look at my parents, then their parents, and their parents, and their parents, all the way until I reach the global scope. And if nothing's there, then I say this doesn't exist. Okay, I don't look in the scopes of things inside of me, or of scopes inside of me, right? So here in this happy function, we create a variable called message, right? And it's in this happy function scope. If I try to log out message when I'm outside of happy function, I can't do it, right? Because I cannot see inside the scope of something that's like my child or my sibling. Yes? No? Yes?
So if let message was outside the function, you could use it both.
Right. If let message was on line 4 or line 9, then this console log would be on the same scope as where the message created. But right now, let message is being created inside this happy function scope. And so basically everything inside happy function is going to be a black box to everything outside of happy function. Right? So I can't even see inside of it to know what it is. So as far as I know, message doesn't really exist. Josh?
Can you define message as I'm sad on line 1, and then can it be redefined as I'm happy on line 6, and then go back to I'm sad on line 11?
Yeah, we'll talk about that in the next time. No, you're good. But yeah, you are able to override variables. But yeah, so this is the crux of scopes. Like if you're comfortable with this, then everything after this should flow really easily. What if a variable is defined both globally and locally, right? Or basically just, what if a variable is defined more than once? And literally this example that Josh just gave, right? Which is, I have a variable called message, I call something globally. I have a variable called log a message, I say act locally. And then in this function, I also try to console log out message. One thing here I'll throw in, and you'll hear me harp on this again probably tomorrow or the day after, is functions. Like if I look at just line 1 to line 11, nothing's running on this page theoretically, because guess what? No functions are being called. On line 5, I create a function, right? But I never use it, right? Line 12 is the only time I actually invoke this function, And the only way to invoke a function in JavaScript is to use these open and close parentheses. So as long as you don't, as long as you don't see any open and closed parentheses on the page, outside of obviously when you create a function, then it means nothing is being run or no code is being run. So I just want to caveat by saying like when I look at line 3, think globally, I'm creating a variable called message. Lines 5 through 10, I'm creating a message, a function called log a message. But line 12 is where I actually run this log a message function, right? And when I run line 12, I then jump back, but I go into line 5 now, and that's when I create this message inside log a message called message, and I define it as act locally. And then on line 9 here, I console log out message. Remember how we're about to talk about scope and how it finds variables, right? On line 9 there, when I console log out message, what message is going to look for? Well, it's going to look for the message in its own scope first. And in this case, it's going to find it. It's going to find a message variable, and the value is going to be act locally. So at that point, it says, I'm done, right? I don't need to look any further. I found a variable that matches what I'm looking for, and I print it out. So that's why on line 9, it's going to print out act locally instead of think globally, right? Because it's going to look in its own scope first, and its own scope is between lines 5 through 10. However, in this case now, what if we define this variable differently? Instead of message, it's called MSG. Then I have a variable called message. I do the same thing as before, except I change the name of this variable, and I run log a message again. Well, log a message on line 13 takes me back to line 5. I say MSG equals act locally. On line 10, now when I console log out message, I'm going to look for the variable called message in my own scope first. And I'm going to say, well, there's no variable called message between lines 5 through 11. Right? There's nothing here. So let me go to my parent scope. In this case, I don't really have a parent because my parent is a global scope. Is there a variable called message on my global scope? And the answer is yes, there is, and it's think globally. So that's why that on line 10 there, when I console log out message, I console log out think globally. Right? So once again, computers, there is no ambiguity, right? There's a very, very logical, precise, consistent pattern to the way it searches for things. And you need to be like very aware of that. Especially if you're going to be kind of using multiple variables for the same name. Parameters also locally scoped. So what this is saying is over here we see any parameters being created. Parameters are things being passed to the functions, right? You're basically creating a new version of this variable. Like that is essentially equivalent to having this like let message equal act locally in between lines 5 and 6, right? So on line 6, when we console log out message, it's going to say, do I have a variable called message in my own scope first? And the answer is, yeah, you do. It's your parameter, right? So just be aware, like the parameters that you see, these parameters are considered like new variables you're creating within your functional scope. Any questions here? So parameters are also variables that you create in your functional scope. And that's why now when I log out a message on line 6 here, it's like, do I have a variable called message in my local scope? I do. It's my parameter message. Great. What's the value of message? Well, I passed it act locally. So when I print out act locally, right? I don't look to the message on line 3 there because I have my own version of message that was created on line 5. Yeah, Megan?
So what would that look like? What would you have to change to make it so that it read the whole scope?
Well, you just remove this, right? So if this variable didn't exist, then it will look for message in its own scope. It would not find it, and then it will look to its parent scope, and it will find it in the global message. But now, because it finds it in its own local scope, it never looks past its own scope. Okay. All right, a few more, like kind of like somewhat like the main idea. Hopefully, you understand. Like everything else is just like kind of like Zanier applications of it. Global variable, I create on line 2 there. Global. On line 4, I have a function called outer, which doesn't really matter to me until line 14 because I actually invoke outer on line 14, right? Like if I just read through this code, if I'm executing this code, right? After line 2, a variable called global bar is created. After line 5, because I haven't invoked the outer function yet, right? I only go through everything. I hit line 14. It says invoke the outer function, and then I go back and then I start doing all of these things inside the outer function. So just because you see a function is being created, it doesn't mean it's being run, right? And the test specs and the workshops you've been doing so far, like you've only been writing functions. You haven't executed any of your functions. You haven't invoked any of your functions yet. And the reason for that is because the tests are invoking it on your behalf, right? If those tests weren't there, then your functions would never run because no one ever runs them. So in this case, in this example, we have a function called outer, right? And we have an outer, in this outer function, once we run on line 14, we have a variable called outer bar, outer, and then we have a function called inner. And in this inner function, we create an inner bar, and we console log out global bar, outer bar, inner bar. So what happens here? Well, actually, we create the inner function, but then we only run it on line 11, right? So notice how every function we create, we need to not only create it, but then explicitly run it for it to do what it's supposed to do. Like creating a function does not run it. It only creates a variable that ties to that function. Running it is the only way to run that function. So if I look at the console log here on line 9 there, well, the first thing it does is it wants to console log out global bar. Great. Is there a variable called global bar in the inner function scope between lines 7 through 10? And the answer is no. I was like, okay, let me look at my parent scope. Who's my parent? Well, my parent is based on where I was created. I was created here on line 7. So let's see. Okay, between lines 4 through 12, that's my parent scope, right? Is there a variable called global bar? And the answer is no, there's not. Okay, let me go out even further. Okay, now I'm on the global scope. Is there a variable called global bar there? Yeah, there is. Great, and it says global. So when I print it out, that's what gets printed out there. Next up, I need to print out outer bar. Do I have it in my own scope? No, I don't. Does my parent scope have it? I do. It's called outer. Let's print that out. And then lastly is I need to print out inner bar. Is it in my own scope? It is. Great. I'll stop looking. And I found it. Right?
So to be sure, right? The function outer, it would not run if you didn't invoke it at the bottom.
Yep. If line 14 did not exist, nothing will print out because outer function would not be running. And similarly, if line 11 didn't exist, the inner function would not run either. All right. These I'll go through fairly quickly. They're just another example, so the same idea. We have a collision, variable called collision. On line 14, we run outer again, and in this we have a parameter called collision. And so on line 8, on line 11 when we invoke inner, on line 8 when we console log out collision, it's going to say, great. Do I have a variable called collision in my own inner function scope? Is there a variable called collision? The answer is yes, there is. Great, we print it out. However, if I didn't have a variable called collision, then it'll say where do I look for the collision variable next? If it's not in my own inner function scope, then does my outer function scope have it between lines 4 through 10? And the answer is yep, I do. It's here. It's a parameter, so I'm going to use that instead. And then lastly, if that also did not exist, then only then do I go to the global scope, right? So you can almost think of as any variable defined on the global scope is kind of like the safety, the backup, like the very last resort, right? Like every other variable named the same way will take precedence over something on the global scope. Yep, and this is just a quick example of how scopes only work in one direction, right? In the inner function, when I console log out my outer bar scope, it's like, do I have it here? No, I don't. But I have it out here on line 4, so I can print it out. But on line 11, do I try to print out inner bar? Can't do it, right? It's in a child scope, right? It's not in my scope. It's not in my parent scope. It's in a scope created within me, so I don't have access to it, and so therefore you'll get the reference error. Inner bar is not defined, right? I think Josh was talking to you earlier today, right? Where in your problem, in your for loop, you had like a let I variable that was created that's only used within your for loop. As soon as you exit the for loop and you try to use I, it will say, well, I can't look into the for loop scope because that's my child scope, right? And so that was why you were getting the reference error for the I. So same idea. Like the idea of scope carries over through every part of JavaScript. Like you can't avoid it. This is literally the same thing as before, so not gonna try too hard. The only thing that I'll say here that's a little bit different is, And I think a few groups saw this already yesterday. Whereas in this case, if you notice how the inner function is expecting an argument, right? Kind of like with the start index, the problem that we just did together as a class. Here, I don't pass anything in. Well, the inner function will still run. It will just assume that this outer variable, the value of it, is undefined. So that's just something to be aware of. Is that like you can invoke a function with the incorrect number of arguments. It's just that everything that you don't mark in is going to be considered undefined. And then lastly, that was fast. Scopes also exist. We use let to create variables. The scope also exists for all curly braces, including if statements and for loops and while loops, etc. So same idea here as before. If I try to console log out block on line 9, guess what? I can't because the variable block only exists within the within the context of this if loop between lines 4 through 7. So on line 9, I get the reference error you see up top because block does not exist on the global scope where the console log exists. Okay. The only difference you might see something called var people being used. It's more of an ES5, whereas let was introduced in ES6. Var works identically to let. The only difference is var only respects function scopes. It doesn't respect if loops, while loops, or for loops. And so basically, let was introduced to kind of offer people a more granular control of where their variables are accessible via, right? So var and let are the same thing, except var, like when you do var here, this ties block to the nearest function scope. In this case, there is no nearest function, so basically this puts block on the global scope. And so you're also able to access block when you're not inside the if statement, the if loop. But for this class, just going forward, assume you always use let and assume that function scopes and block scopes are the same. Okay. Last concept we'll talk about is the idea of hoisting, and this goes back to what I said earlier about this idea that JavaScript reads your code, actually reads it twice. The first time it reads it, what it actually does is it's kind of making a checklist of what's available, and the second time it actually goes through and tries to execute everything. Here on line 4, we'll say something like, we want to execute this function, and we write, will this work? And if you notice, we invoke this function before we define it, so to speak, right? This function definitely comes after this. But when we try invoking it, you'll see that the answer is yes. In fact, it does work. And the reason why is because there's two ways to define a function. One's called expressive and one's called declarative. So,
So just
Yep.
a comment. These slides aren't included on the one.
yeah, they're not.
Okay.
Yeah, like the ones we have are like kind of like we change these kind of on the fly. So sometimes they're not like word for word, side for side, exactly what it is in there. Okay, so in this case is a function declaration, and the way that we know it's declaration is because we just use the function keyword directly and we just create it. And let's contrast this with this fellow here, where we're also creating a function, right? Except now what we do is we actually create this function, this variable called will this work first. And so on the first pass, when JavaScript reads this, what it's actually going to do is it's going to create this variable called will this work. But what's the value of will this work? So after the first pass. Nothing is never an answer in JavaScript.
Undefined?
Undefined,
Undefined, there you go.
right? Because the first time we pass through it, it'll say, great, there's a variable called will this work. It doesn't know what it is yet, right? It could be a number, it could be a boolean, it could be a string, it could be anything. It's undefined. And so then the second time when it tries to actually run this, it'll say, oh, I can't, oh, this is the error, by the way. This is sorry guys, this is embarrassing because it's like the entire point is this doesn't work. But let me change the slide. But like this will not work. This will throw a reference error because the first time JavaScript goes through this, it will say, will this work? Is a variable, its value is undefined. And the second time it'll try running it, and it'll say, hey, I can't run undefined, it doesn't work. So yeah.
So we'll just stop there at line 4.
It will throw a reference error at you,
Okay.
and the code will stop, yes. Okay, a few more, and so, and just so you guys know, the reason why like there's two ways to write a function, or rather, the reason why you would pick one way over the other, obviously in the first case where you use a function keyword directly, it's a lot more flexible, right? You can just write a function, no matter where it is on the page, you can call it right away. And the second way, that's useful for some other like more edge cases too. If you Google like declarative versus expressive functions, it will give you a bunch of scenarios in which one is preferred over the other. But for the purpose of this class, you're pretty flexible to use them however you want, really, right? Because you're only writing in most cases one function at a time, like in the confines of the test spec. So for this class, it doesn't really matter. In the real world, there are some nuances, but like I said, they're kind of like more edge cases. They're not like common day-to-day things. Generally, you'll see both being used pretty commonly. It's also the reason why, actually, I'll go through this slide, then I'll talk about one more thing. So scope best practices. You almost always, so, okay. So here's an example of us creating we'll say a global variable on line 2 there called always true. And in the middle, we have this function called don't mind me that actually changes always true from true to false, right? And so on line 10 there, when we run if always true, we might expect that always true is true still, but the answer is it's not, right? Because in the middle, someone else changed it. And so this is an example of why global scopes are actually fairly cautioned against. If you create a global scope in JavaScript, some editors will probably even throw like an error at you telling you, hey, this is a global scope, like don't use it. And the answer is, and the reason why is because global scopes are, because everyone has access to it, like when you use a global variable, you don't actually know who's touched it or modified it or done something with it before you get to use it. Because by definition, global scope means everyone has access to it at all times. And so that's why global scopes are not very like common, and you'll be warned against using them. Usually you want your variables to always be inside a function, so you know exactly who has access to those variables at any given time. The other thing to note is that the fastest way to create a global variable is in JavaScript. You actually don't even need a let keyword to create a variable. You just do like David equals 6, and it will create a variable called David. But what that does is if you don't use let, it will automatically put that on the global scope. Too. So that's why a lot of times if you create a variable without using the let keyword, you'll be like, oh, this works too. This is great. I'll never need to type let ever again. But in that case, what you're doing is you're sacrificing the ability to put it in a certain scope. Yeah.
Is that why in like for loops and stuff you would put let I or let
Yep.
whatever?
When you say let I equals 0 in a for loop, it basically makes that I only usable in the confines of the for loop. If you just use I equals 0, you've now created this global variable called I that anyone can modify if they wanted to. Cool. Yep. So if you ever want to change anything, you always want to, if there's a global variable and you want to use it, always kind of redefine it or create like a local version of it that you can use, that you're not kind of, so that you're kind of you're insulated from the effects of other people modifying your global variables. So the short version of this is just don't use global variables. It's kind of dangerous. And then the last thing I'll say is in general, like if you look at like kind of well-written code, it tends to follow like three formats. People tend to define all the variables at the top of the page first, so everyone can kind of see what's there or what's going to be used with the course of the page, and then people define the functions, and then people run the code. Depends on how you define the functions. If you define the functions decoratively, people might also do like all the variables first, and then all the code execution, and all the functions get defined at the very bottom. Because when you define a function decoratively, you can run it wherever you want on the page. But the short version is the variables always come on top of the page. That way you don't run into any errors where variables are used as undefined, because if the first thing on the page that runs, they'll always get their values before anything else runs. And then secondly is, so when I look at your code, I kind of have a good sense of what variables you'll be using over the course of the work. Yeah, yes, sir?
The structure, does that hold the same within writing its own function? Like
Yep.
all the
Within every function, you'll see all the variables get created first, then your choice of running it or creating the functions within it. And so even if you're writing like an if statement, right, or a for loop, like you always kind of want to follow that similar convention where the variables go at the very top. Yeah. Cool. Any last questions on functions and on scope or functions or hoisting. Hoisting is just the reading something twice. Usually when it says when we say hoisting, what it means is on the first pass through, we kind of take all the variables and we hoist them to the top. So we pretend like they're on the top of the page on the time of the second read through. So that way like all variables exist even if their values aren't determined yet. Right? Because hoisting just means brings to the top. So it's a Any questions? Good? Good. All right, awesome. Yeah, so we have until it's 1 now. We'll say we have 2 hours for lunch plus workshop. And I'll start the review for this probably at 3 o'clock today. So I will send out partners now.